Good morning, afternoon, or evening, wonderful children. We are about to embark on a journey of math here. The semester one study guide. I'm excited about this. Let's get right to it, shall we? Alrighty, first one. Vanilla Ice just purchased a home in West Palm Beach, Florida. That is actually where he does renovate some homes. He plans to install tile in the entry and kitchen. How many square feet of tile should he order? And also, if the tiles are 4 inches by 6 inches, how many tiles should he order? All right. So we're talking about the entry and the kitchen. I will go ahead and outline that in red. Beautiful. So we got ourselves a rectangle, right? That kitchen is 8 by 20, so we can go ahead and toss an 8 right there. Let me make that a little, that's better. All right, so 8 feet. And then if the kitchen is 20, but if we look above here, that's 20 by 30. So the living room is 20 going up and down here, right? But the dimension I really want is the 30 feet all the way across, okay? So I've got myself an area of 8 times 30, which gives me 240 square feet. So first question answered. Boom. How many square feet of tile should he order? Now the next part, you can go about this in a couple ways, okay? Well, I could find the area of one tile. And that's 4 times 6 is 24 square inches. So I've got two different units here, right? 240 square feet, 24 square inches. Something's got to change. So either I need to convert the area of the entire thing to square inches or the area of one tile to square feet. Either way is okay. I'm going to go ahead and change the area of the entire entry and kitchen to square inches. All right. So if I take 240, and I'll go different color now, 240 times, there's 12 inches in 1 foot, but we're talking area, so our units are squared. So really I'm multiplying by 144. So I'm going to go ahead and plug that into my calculator. 240 times 144. And now I have 34,560 square inches. That is my area right there, but in square inches. Now I can just take that 34,560 and divide it by the area of one tile. So divide that by 24, and I'm going to get 1,440 tiles. Boom. Done. Excellent. Now, of course, we're going to have to do some overages and things like that, but that would be like the exact amount of tiles that we would need. Another way of going about this is figuring out how many tiles could I fit in 1 square foot. And you can go do that way too, but you should still get to 1,440, okay? I'll go ahead and show that off to the side here. So I would have, let's see here. A tile is 4 inches by 6 inches, so that would be 2 tiles going across here for 12 inches total, 6 and 6. And then I'd have one, let me go a little bigger, 1, 2, and then we got 4, 4, and 4, so that's 12 out there, right? So I've got 6 tiles per square foot. So I've got 240 square feet to fill. So that would be 6 for each one. 240 times 6 gives me the same 1,440 for my tiles, right? 1,440. That way I think some of it we might find a little bit easier, but we don't always have perfectly square foot fitting tiles. Like if they were, 8 inches, 4 inches by 8 inches. Well, now it's a little bit trickier to kind of fit together in 1 square foot. So I like the one that I have over here, which is why I did that first. Okay, let's keep going. Boom. Number 2 here. Find the area of these building objects. All right. Area of a triangle is 1/2 base times height. That's a formula you should have committed to memory, okay? Well, my base is 28 and my height is 6. The base and the height are always perpendicular to each other. They have to be perpendicular. So here I'm going to have area equals 1/2, and then base is 28, height is 6. So if I multiply those all together, I get 84. Let's see here, it's square feet, so that's an acceptable notation. Awesome sauce. Wonderful. Fantastic. Awesome. All right, next one. Area of a circle here. That's a circular window. That's kind of fun, right? So area of a circle, that's going to be pi times my radius squared. Well, it already gives me a radius of 1.2, right? So I'm going to have area of the circle is equal to pi times 1.2 squared. I'm going to plug that into my calculator. So when I do pi on my calculator, I want you to use that pi button, not 3.14. All right. I want you to use the actual pi button. It's more accurate. I'm going to get, let's see here. We got 4.523. 4.523, and it goes on forever. So we're going to go ahead and say about 4.5, and that's again feet squared. Awesome. Fantastic and wonderful. Ooh, whoa. A regular pentagon deck. Someone's going crazy with their deck designs. I love it. Excellent. All right, if you remember, our area of a regular polygon is 1/2 times the apothem times the perimeter. Okay? Well, my apothem, that's A right there. My perimeter I can find from one side and multiplying it by 5. So A is equal to 6, and my perimeter is equal to, well, there's 5 sides at 10 feet apiece, so that's 50. Now I can plug this all into my calculator, or actually into the formula first, and I can actually probably do this one in my head. These look like decent numbers. All right, area is 1/2, and then I got my apothem is 6, and then my perimeter is 50. 1/2 times 6 is 3. 3 times 50 is 150. Again, we're using feet, so square feet. Awesome. Wonderful. Keep moving. Keep moving. All right. Ooh, trapezoid. Woo! Area of a trapezoid. I'm going to change markers already. All right. Area of a trapezoid is, we're going to have to take into account both of our bases. And there's a couple ways of writing this one. We have 1/2 times base 1 plus base 2 times my height. Or you could do base 1 plus base 2 times height all over 2. We'll go with this one. It kind of looks a little bit like a triangle formula, but there are 2 bases to take into account. So if I'm going to plug that into my formula here, I've got 1/2, and then my base 1 is my 8 feet. My base 2 is the 12 feet. And then my height, the height, remember, is perpendicular to the base. In this case, both bases. So that's the 1.5. That 3 foot there, that 3, that's there to distract you, kind of. It's going to be like, that's just a side length, right? So we can find the perimeter if we wanted. But here we're asked for the area, so we got to use that base. So if I plug this all in, I've got 1/2 times 20. If I do a little bit of mental math here, that's 10 times 1.5. That's going to be 15 feet squared. All right? If you plug that all in your calculator, you should get the same thing. Cool. Awesome. Fantastic. I like to do a little mental math whenever I can. Woo! This one looks like a composite figure. Oh, man. Oh, man. I'm going to go green. All right. So we can break this thing apart in one of 2 ways, really. All right. We could go like this, and now I have 5 times 10 plus 3 times 3. So I'm going to have 50 plus 9. So my area is 59. And I'm going to come down here a little bit. Area equals 59 feet squared. Love having units. You could have also broken it apart the other way, and that's fine too. You should still get the same answer. You could have gone here and then have different numbers, but this one seemed the easiest to me because I see dimensions right away. All right, parallelogram. Parallelogram, bro. All right. Formula for that is going to be base times height. Okay? But remember, my base has to be perpendicular to my height. So what's that going to look like? Well, my base is going to be 10, which is perpendicular to the height of 7. So my area equals 70 feet squared. Cool. Awesome. Wonderful. Fantastic. It's a great little review of some area. Let's keep going here. Page 2. This is going to be a decent length video, I think, here. But hey, whatevs. All right. Find the area of a stop sign, which is a regular octagon. Each side is 10 inches, and the apothem is approximately 12 inches. I'm going to go ahead and check this out. Let's see if it works. I really thought it was going to work. That's a real bummer. Anyways, I got 8 sides, but maybe I should change that to red here because it's a stop sign. All right. No longer ink to shape. Thanks for nothing. Okay. So each side is about 10. And the apothem is approximately 12 inches. Remember, the apothem is from the center, perpendicular to the side. I basically have everything I need here, almost. The apothem is 12. My perimeter is going to be 10 times, there's 8 sides, so 80. So now I have area of that the regular polygon is 1/2 times the apothem, which is 12, times my perimeter, which is 80. Let's see here. That's 6 times 80. That's 480, I think, inches squared. I'm going to double check that. Boom. Just checked it. Plugged into the TI-84 just in case the mental math was right on point. All right. Boom. There we go. Awesome. Number 4. What is the area of the deck surrounding the hot tub? I've got 2 circles here, an outer circle and an inner circle. I want the area of the deck, which is that shaded region there. So if I find the area of the outer circle and subtract the area of the inner circle, then I should be Gucci, as they say. All right, so area of the big circle we'll do in red, and that's going to be pi times, what's my radius? 24 divided by 2 is 12 squared. So we got 144 pi. I'll leave it like that for now. The next one is, let's see here, area of the inner circle. Well, it's pi times, and it looks like my diameter is 10 down here, so radius is 5. All right, we get 25 pi. Cool. So now I can do 144 pi minus 25 pi, and we can get ourselves a wonderful exact answer. Let's see, it'll be 119 pi, and that would be feet squared. I can also plug that into my calculator. So if I just type in 119 times pi into my calculator, I'm going to get 373.849, so 0.8 feet squared. That would be acceptable as well. All right, if it's multiple choice, find which one it is. If it says, give me an exact answer, that's the 119 pi. If it says round to the nearest tenth, there's your answer, 373.8 feet squared. Awesome. All right, an 8 by 10 bathroom and a 10 by 10 bathroom is being tiled with 4-inch by 4-inch tiles. How many tiles do you need for both bathrooms? Okay, well, how about this? Bath 1 is going to be 8 by 10, which equals 80 feet squared. Bath 2 is 10 by 10, which is going to be 100 feet squared. Cool. So total area is 180 feet squared. This is kind of like the other problem, right? Now I have 4 by 4 inch tiles. So my tile area is 4 times 4, which is 16 inches squared. So I got to make some conversions here. Potentially. You could do the layout and figure out how many tiles in each one. This is going to be a more universal approach. So this is what I'll do. I'm going to go ahead and convert this to inches squared. So I need to multiply by 144, or I'm going to say 12 squared. So that's going to give me, so 180 times 12 squared, or 144, is going to be 25,920 inches squared. And now I can take that 25,920 and divide it by 16. That's each tile. So divide that by 16. I just got it in my calculator right now. No big deal. I've got 1,620. What up, Jenny? She wants to go outside. I think I'm going to have to let her out. 1,620 tiles for both bathrooms. Cool. I like it. Awesome. I'm saying awesome a lot. I'm just going to keep going with it. All right, next one. Find the area of the roof and siding of the garage pictured below, even the hidden sides. The slope of the roof is 912 and has a 1 foot overhang. The length of the garage is 20 feet, but the length of the roof is 22 feet. Okay, so we do need to take that into account in this one. We're not always prompted for that. This one we are. You will need to calculate some missing dimensions. So give you a hint here. You'll still need the height of the gable end roof and the length of the slope part of the roof. All right. So we got a bit of work to do on this one here. Let's try to stay organized. So I need to figure out what the height of that gable end. I'm going to draw this line in right here. I need that height. It's a little off. Guess that's better. So I need that. Okay. Well, I do know that this right here is going to be 8. This is going to be halfway across, right? If we're framing this up correctly and it's not all crooked. And I know that my pitch is 912. So 9 rise and a 12 run. And right now I want to know what my rise is if we have an 8 foot run. So I'll have to cross multiply. So I'll have 72, and this is going to be my x right here. So 72 equals 12x divided by 12. I want to say this is going to be some kind of a decimal here. So 72 divided by 12 might be like 7.5 or something. 6, not a decimal. I can do math. That's right. It would be 6. All right. So x equals 6 feet. That's 6 feet. All right. Cool. So we got the height. I like that. So now I've got enough, it looks like, to figure out the area of all the sides, right? Okay, so I have, let's see here, 9 by 20, right, for the side. So let's say side is 9 by 20, which gives me 180. But there's 2 of those, so times 2 equals 360 feet squared. So that would be my side elevations. And then the front and back, we'll say front and back. That's going to be 2 things. One is going to be 9 by 16 plus, then I have the triangle up top, right? So we have 1/2, and then my base is the 16, but my height is 6, okay? And what's that give me? So we have, so this would just be for one of them. I guess we could do this. Put it all in parentheses, and we're going to have to double that. Okay? So I have 9 by 16. I don't want to make a mistake. I'm going to throw this in my calculator. Plus 1/2 times 16 times 6. That's going to all give me 192. But that's all times 2. And then that, and I get 384. Yep. Feet squared. So if I put those 2 together, total, we'll say like siding or whatever you need for the outside, is going to be, let's see here, plus 360. We get 744 feet squared. That's our total for all the sides. Now let's do the roof. And I'll do the roof in red because the roof is currently pink and it kind of matches, but I think pink won't show up that great. All right. So sides are good. We accounted for the hidden ones. Time to do the roof. So we already know from the prompt that this length is 22 feet, but we need to know what this sloped part is. I'll call that y. All right. Now, how am I going to figure that out? If we think about our most recent unit, or one of the most recent ones, Pythagorean theorem, right? I have 6 squared plus 8 squared. So 6 squared plus 8 squared equals y squared. And actually, if you remember your triples, this is going to be 10. But we could work it all out. We have 36 plus 64 is 100. So y squared equals 100. So y is going to equal 10 after we square root on both sides. So 10 feet. All right. So my roof, that one's actually not too bad. It's just a couple rectangles. So we have roof equals, and it's going to be 22 times 10, which is 220 feet. But there's 2 sides, so we're going to get 440 feet squared. All right. So total for the roof is that, and total for the siding is the blue. I'm actually going to print this as a PDF, so roof, and then siding. All right, I like it. Cool. Find the surface area of the roof, the shaded part. Remember, there are 2 sides of that roof, meaning the stuff behind, not just that there's 2 pieces of it. All right, this is a kind of a cool little barn-style roof. I can't remember the official name of it. I should look that up. All right, so let's go ahead and do this. It looks like we got an 8-foot section by 32 and a 4-foot section by 32. So 8 times, not 42, 32 is going to be, what is that? I don't want to make a mistake in this video. 256. That's right. Okay. And then we have a 4-foot by 32, right? I'm getting this 32 from down here. And that is going to be 128. And if we add those 2 up, I get 384. But that's only for what we see. So I do need to multiply this by 2. And I will get my final answer of 768 feet squared. Okay? So we got our hidden 2 sides. That's going to be everything. I love it. Ooh, algebra review. I'm into that. Okay, solve for x in each situation. So I'm going to have to distribute this 3. So I get 146 equals negative 7 plus 21x plus 6. I'm going to combine some like terms. 146 equals 21x minus 1. I'll add 1 over. 147 equals 21x. 147, is that divisible by 21? I don't know. It is. X equals 7. All right. Distribute my negative 5 here, right? That is a negative 5. So I have 6x minus 30x minus 40 equals negative 184. Combine some like terms. So I've got negative 24x. I'll add 40 over here while I'm at it. Save a little time here. And I'm going to get, let's see here, negative 144. And if I divide that by negative 24, I'm going to get 6. It's a bad 6. So x equals 6. Okay. New color, new problem. Looks like I don't have any distributing to do here, just combining of like terms. So I'll do a negative 11 plus 2x equals x minus 3. Now I got to get some variables, your x's together and move that 11. So I'll add 11 to both sides. I can also subtract x in the same step. So that's gone. This becomes x. That's gone. And this becomes 8. Okay, I'm done. Awesome. No dividing in that one. Cool. Did I circle it? I did. Good. All right. Find the surface area. Include all surfaces. Woo! This is a beefy problem right here. If you I tell you what. All right, we're going to start with our cylinder first. Okay, let's do this. So first with the cylinder here. And what we're dealing with our surface area, we got to put some things together, right? We've got circles, so I know an area of a circle is pi r squared. And if you remember for a cylinder, it's the wrapping around it, right? The lateral area, as we call it, that is going to be a rectangle. So the lateral area, the part that goes around it, that is going to be our 7 is our height, but our base is actually the circumference of the circle. It's the distance around here that will give us that. So what we're going to have here is 2 pi r times my height. Okay, that's what the lateral area is for that one. I always like to just remember that it's a rectangle and think about what dimension that would be of that circle. So let's go ahead and put this together. So I've got a circle. So area of the circle part is going to be pi times, it looks like a radius of 3 squared. So that's 9 pi, but there are 2 of them, right? So times 2 gives me 18 pi. All right, so there's one of them. And then I'll go ahead and get the rectangle. That is 7 times and then our circumference. So let me zoom in a little bit here. So we got the lateral area is going to be 2 pi times the radius of 3. It's a terrible 3. And that would be, and then also times our height, which was 7. So I've got 6 times 7 or 21 times 2, that's 42 pi. Okay. So if I put those two together, 18 pi plus 42 pi, that's 60 pi. Actually, so that's the total surface area equals 60 pi. And that was feet. Yeah. Feet squared, or if we do an approximation, which would be the squiggly equals, so 60 times pi, that's going to give me 188.4955. So let's say 1 decimal place, 188.5. 188.5 feet squared. Get both of those. Whole thing. Boom. All right. So there's my final answer for that cylinder. Let's go up into the square base pyramid. Okay. I'll go different colors so things don't get mixed up. I'm going to go more drastic, though, with my color change. I'm going to go purplish. Okay. So for a square base pyramid, it's just triangles and squares, right? So the base, let's just say this, the area of the base, actually, I'll call that big B. That's going to be 8 times 8, which is 64 feet squared. I'm kind of encroaching over there. I'm going to write that below. 64 feet squared. Okay. And then my triangles are all, if that's 8, right, this is going to be 8 as well. So I have a bunch of triangles. Area of a triangle is 1/2 times the base of 8 times 15, which is perpendicular to it, right? So I'm going to get 60 there. feet squared. But there are how many of those triangles? There's 4 of them. So I got to multiply that by 4, and I get 240 for what's called the lateral area, all the triangles wrapping around. So my total surface area equals, and that's going to be the 64 that we had plus 240. So 64 plus 240 is what, 304? 304 feet squared. Final answer. Woo! All right, saved a little space by getting a little more vertical there. Time for the cone. Oh boy, this is awesome. All right. Oh, I'm happy about this one here. This is going to be great. Okay, so I have the height of my cone, which is 7 feet. What I need for the surface area is actually, and let me do this in a different color here. What I need for this one is actually, I'm going to go to, let's see here. How about blue? There we go. I need this one. I need the slant height. Well, this is going to be perpendicular. My height's going to be perpendicular to that base. How would I figure out that missing dimension? Pythagorean theorem. I thought you'd never ask. All right, so 3 squared plus 7 squared equals c squared. So I'm going to get 9 plus 49. And then I'm going to go ahead and square root that. And I'm going to get, we'll say c is the square root of 58, which is also equal to 7.6 when we approximate it. But I'm going to go with the square root of 58 to keep things accurate, okay? So now I've got that slant height. The area formula here is pi times my radius times my slant height. That's the L there, the cursive L. So once you have that information, it's actually a pretty easy formula to plug things into. So pi times my radius of 3 times the square root of 58. That looks like not a 5. There we go. And that was not going to be very nice for like an exact end. I mean, you have to leave it like that to be exact. But I'll go ahead and plug this all into my calculator using that pi button, right? And that's going to be a final answer of 71. Oh, not final answer. 71.776. I'm going to leave this like this for now. 776 and change. What did I forget about here? I forgot about the area of the circle. All right, so keep this one in mind though, right? We're going to keep that in mind. So the area of my circle here, my circle base, is just pi times the radius squared. So pi times 3 squared, which is 9 pi. And now I can add those two together. So let's add 9 pi to that. So we've got total surface area equals 71.776 and change plus the 9 pi. So add 9 pi. Oops. And I get a total surface area of, once I round, it's going to be 100.05. So we'll call that 100.1 feet squared. Cool. I like it. Awesome. Whew. This is some stuff, man. This is a lot of stuff. We're still moving here. We're still moving. All right, I'm going to scooch over to some red marker on this one. Regular pentagon. All right. So we got a regular pentagonal prism that's going on. Prisms are wrapped in rectangles. Pyramids are wrapped in triangles. All right, so this one is wrapped in rectangles, so it's a prism. I've got pentagons and I've got rectangles. Well, we've already reviewed both of those, right? The area of a pentagon, area of that pentagon is 1/2 times the apothem times the perimeter, okay? So this would be my pentagon, my bases, right? The big B. So pentagon, that's B. All right. So let's see here. We got to do a little bit of work for some stuff here on this. Oh no, gives us our apothem. Awesome. So we have 1/2 times my apothem of 4, and then my perimeter. If one base is 5, then my perimeter is 25, right? P equals 5 times 5. I'm going to put that in a space that's not in the way. P equals 5 times 5, which is 25. Okay. So here we've got 100 times 1/2, which is 50. But there's 2 of them, right? So times 2, that equals 100 for both bases. Both bases. All right. So that's one of them. Then I need my rectangles. Well, all my rectangles are 5 by 10, right? So the lateral area is 5 times 10. How many sides are there? There's 5. So I'm going to get, let's see here, we got 50 times 5, we get 250. Right? And then I'm going to put all that together. So total surface area equals, and that's going to be 100 plus 250. That's 350 feet squared. Make sure you got those units at the very end, right? Total surface area is that. Okay. Cool. Awesome. Whew. Man. So these are some quality problems here. Quality problems. All right. We'll do one more here. I'm going to switch colors again. I don't even know what other colors we got. Like maybe orange or darker purple. How about a darker purple? Okay. Again, we have a prism here. This is a triangular prism. Okay. The triangles are our bases. The rectangles that wrap around, that's our lateral area. So the area of the triangle, which would be our bases, would be 1/2 times base, which is either 8 or 6. I'll go with 6 times my height of 8. So that's 1/2 times 48, which would be 24. But we have 2 bases. 2 bases equals 48 inches, it looks like, for this one, inches squared. Sometimes I forget my units, I think, along the way. Most important is units at the end there. Unless we have like a lot of different units throughout the problem, then you really got to keep them straight. Okay, so now my rectangles. It looks like we actually have different rectangles this time. So lateral area consists of looks like a 20 by 10. We have a 20 by 8. And we have a 20 by 6. And if I add all that up, I get 480. And then if I add that to my 48, I'm going to get, so a total surface area of 48 plus 480. That is going to give me, drum roll please, it'd be 528 inches squared. All right. Man, it's a lot of work right there. It's beautiful. Look at all the wonderful colors. All the wonderful colors. Okay. Let's go to some applications, shall we? All right. Number 10 here. Vanilla is adding a dormer, picture below, to his dope Palm Beach flip. He needs to know how many squares, 100 square foot quantities of shingles to order. Make sure to account for both sides of the roof. So this dormer here that we have, it looks like, so it comes back there like this, up, and over. It's actually a trapezoid. I know that it kind of looks weird with the three-dimensional stuff, but it is a trapezoid. So if I were to draw this out, I'm going to make the short side up top. The shape it is something like this, where this is the 10 foot, this is the 13 over here, and then this is 4 foot, okay? The unknown one is that angled piece, which is okay because these are the 3 pieces that we need to find the area here. So the area of a trapezoid, which is what we're dealing with, even though it's not an isosceles trapezoid, it's a trapezoid no less, is 1/2 times base 1, so 4 plus 10, oh my goodness, Jenny, times our height. We just got mail. That's why Jenny's barking. Okay. And then multiply by my height of 13. So if I go ahead and put this all together here, I'm going to have 14 times, or plus 10, or sorry, 4 plus 10 is 14, times 1/2 is 7, times 13. That's a terrible 13 there. That equals 91 feet squared. But keep in mind, remember it said, make sure to account for both sides of the roof. So I do need to multiply this by 2, and I'm going to get 182 for my total area. 182. All right. 182 feet squared. Cool. So how many squares of shingles do we want? Those are 100 square foot quantities. So if we divide that by 100, I'm going to get, so I'll do that up here, 182 divided by 100. That's going to be 1.82. So we'll say 2 squares. Okay? Awesome. Ooh, challenge problem. All right, so Vanilla Ice came into some free patio pavers from a neighbor down the street, Marky Mark Wahlberg and the Funky Bunch. All right, he has about 1,000 6-inch by 3-inch pavers and wants to make the semicircle patio picture below. All right, Jenny is busy policing the neighborhood right now from her bedroom. All right, so let's see if we can get through this now. So he has about 1,000 6-inch by 3-inch pavers and wants to make a semicircle patio pictured below. It has a radius of 12 feet. Does he have enough to get the job done? So we're dealing with a semicircle, half a circle, with a radius of 12. Well, how about this? Let's find the area of a circle with a radius of 12 first, right? So pi times 12 squared. So 144 pi. And since it's a semicircle, it'd be half that. So what, 72 pi feet squared? Cool. No need for the calculator yet, right? Those are some decent numbers. I can just keep it in terms of pi. Now, he has about 1,000 6-inch by 3-inch pavers. Why don't we figure out what the area of the pavers is that he can cover, right? So if I say area of pavers, so I'd have 6 times 3 gives me 18 inches squared. And then he has 1,000 of those, right? 1,000 times 18 gives me 18,000. Not pavers. Inches squared. That's the inch in coverage. And this is where it really helps to keep track of your units, right? The other ones we were dealing with all the same units as we were getting the different bases and things like that. So not labeling was okay until our final answer. Here, we have 2 different units, so we're going to have to do some kind of conversion here. It's up to us what we want to do. If we want to convert the original area of the semicircle or if we want to do the pavers, I don't care. How about this? I'm going to go change the pavers to square feet. We haven't done that version yet, right? So I'm going to divide by 12 squared, right? My square footage should be a smaller number than the square inches. So if I take 18,000 and divide it by 12 squared, which is 144, I'm going to get 125 feet squared. That's the total coverage of pavers. Currently, I have my other one in terms of pi, so how about I multiply out 72 times pi? So if I do this, this area here is 226.19 feet squared. So clearly not enough, and especially if we add the 10%, which is we're going to have 226.19 and change times 1.1, not 1 times 1, that looks like 1 times 1, 1.1. So if I were to multiply that by 1.1, my total area that I needed to cover with that waste is actually 248.8 feet squared. So unfortunately, not enough. And our work would justify that. Cool. All righty. Sorry, Vanilla. Not enough. Okay. Next unit now.